Hello, today we'll talk about acronyms, API, MCP, A2A, why they're important, what they mean for enterprise localization and translation, and so on. So there have been many years when if you wanted to make two software systems work together, you would do that through an API integration. And yet, as you know, some software systems still don't have good APIs, and some API integrations, actually many API integrations, still such a pain. Now we have to deal with two more acronyms, MCP, or Model Context Protocol, and A2A, or Agent-to-Agent Communication Protocol. MCP was introduced at the end of 2024 by Anthropic and now adopted by many other companies, including OpenAI and Google. And A2A was introduced maybe a month ago by Google. So let's discuss the difference between these acronyms and what they mean for translation, enterprise localization, and language engineering. And specifically, there are MCP and A2A use cases that may significantly elevate a localization team inside the organization. And I'll talk about that. But let's start with an API. So API, or Application Programming Interface, is what you use when two software programs need to talk to each other, usually over the internet, but not always. All software interoperability today is built on APIs, especially so-called RESTful APIs. So when your content moves from content management system to your translation management system, that exchange happens using an API. Typically, there is a connector involved. It's a piece of middleware which talks to two APIs. It receives signal from CMS that new content is ready, and it pushes this content to your CMS, creating a translation project. And then, when this project is complete, the same connector pushes the new language version back to your CMS. That's a classic API use case. It's clean, structured, and predictable. Now, let's bring a bit of AI into the mix. Even though APIs are built for software-to-software interaction, they're also used today where to use AI in your software systems. If your TMS wants to use machine translation, it calls the API of an AI vendor, like a translation engine or a large language model or Intento. That AI model can be a neural network running somewhere on NVIDIA GPUs, but it's made accessible to you through an API. So when you need to translate a segment, your system sends a structured request. Here's the content, here's the source and target languages, here's the model I want to use. This is a very deterministic operation. You know exactly what will happen unless there is a technical error. It's just like calling any other software function. And that's the point. APIs are deterministic. They're how you make distributed software systems work together, even when one of them happens to use AI under the hood. Now, what happens when you want to use AI on your end to do more than just follow a fixed path? What if your AI needs to decide what tools to use or pull context by itself from multiple places dynamically? Because that's the whole idea of AI. It should have agents, it should have decision making, right? So that's where MCP, or Model Context Protocol, comes into play. Anthropic proposed MCP to make it easier for AI models and solutions access external tools without you, the developer, having to hard code every tool you want to use into the prompt. With MCP, it's the vendors of those external systems who define how their tools can be and should be accessed using this shared protocol. Say you want to inject business context into your translations, and this business context is spread across 60 different content management systems, 10 internal directories, product information management system, and a couple of terminology databases. So if you're building an AI translation solution for your localization department, you would otherwise have to define and describe each of these tools by hand and send this information with every prompt. Such a pain. There are technologies such as function calling and tooling. They can make it a bit more convenient, but still the burden of building the connector is on you, the AI solution developer. With MCP, each of those CMS and terminology systems will just run an MCP server. That server exposes what the system can do in a way that any MCP-compatible large language model can understand. So instead of defining all those tools yourself, you just provide a few links to those MCP servers. Now any AI agent across your organization can access those tools as needed. Even if you build multiple AI agents in your localization department for different pieces of work, they all can use the same MCP-defined tools. And there is another important use case. Say you have your own custom AI agent for translation, similar to what Intento provides to its customers. It can handle translation following your terminology, tone of voice, nuances of your style guide. But all other units prefer to use ChatGPT or Claude or Gemini to their, daily language chores, including translation. So you can build an MCP server and connect it to your internal LLM deployment so that every translation request made by any user in ChatGPT will be fulfilled by your AI agent, which your team provides. It's something like, setting a redirect from Google Translate to your secure enterprise translation portal, such as Intento portal. Think about that. But what if you go beyond tools and data and you want multiple AI agents to collaborate? Just imagine your headquarters marketing agent generates some content and then hands it off to transcreation agent, which does this transcreation and then sends it to legal agent for review. And this legal agent may be provided by a third-party company. Now, this legal agent may return it to transcreation to fix something, and they may iterate, and once everything is finalized, it goes to regional compliance agent that validates it in Korean, where the local regulations aren't even documented in English. So that's a non-deterministic workflow, and you cannot really map it into a series of API calls or set of tools to use. It's human-like. So yes, you could technically call those agents through an MCP as they are just tools, but what if you need to iterate, revise results, escalate decisions? That would require a kind of centralized orchestrator agent with complex logic, and you essentially lose this benefit of agency across all your organization. So that's where the agent-to-agent protocol, or A2A, comes in. It's developed by Google and it's designed specifically to handle these kinds of non-deterministic multi-agent workflows. It's not about calling a tool once and returning a result. It's about building systems where AI agents can cooperate, negotiate, and chain together to complete complex tasks, just like we humans do. And this is another very important point for localization teams. All major players now admit that although there may be a centralized LLM deployment in the company, every business function needs to own its AI agents that embed and scale expertise of this business unit and its subject matter experts. So those agentic interoperability tools actually create kind of a space for translation AI agents, which could serve translation to other agents, including customer support, legal, and so on, and they will be managed by your team. So to wrap it up, APIs are the backbone of modern software. MCP gives AI a structured way to use external tools and context without those boring integrations being an AI developer, your responsibility. And A2A takes this kind of step further, letting those AI agents collaborate like teams of people. In localization, we need all three: APIs to integrate our platforms, MCP to plug business context, business knowledge, and tools into AI solutions, and A2A to orchestrate intelligent workflows that mirror how real content creation and translation projects evolve across departments and languages. So that's the landscape today, and it's moving pretty fast. There is already a new version of MCP in works. Stay tuned and make sure to add these MCP compatibility requirements to your next RFP.